Rational exponents are fractional exponents. So here we have our rule. B to the fraction m over n is equal to the nth root of b to the m. So the exponent has a denominator that becomes the index and a numerator that becomes an exponent to the base. And that base goes in the radical. Now there's two different ways that you can write this, but either way, the denominator's value from the exponent becomes the index. And then the numerator becomes the exponent. Now, depending on the problem that we're working on, sometimes it's easier to use this first definition, and sometimes it's easier to use the second. And I'm going to model what they look like. Here we have 27 raised to the 2/3 power. I can rewrite this as the cubed root of 27 squared. And in this case, I would have to figure out what 27 times itself is, and then take the cubed root of that product. Or I can use the second part of the rule that says the cubed root of 27, and then square the result. And that's typically what we're going to do with these rational exponents, especially when we have numerical bases. When we have that numerical base, we're just going to say, what's the cubed root of 27? Well, the cubed root of 27 is 3. And then 3 raised to the second power is equal to 9. So we'll have 3 raised to the second power, which is equal to 9. We will get to the point where we are doing these in our head. For instance, if I have, let's say, 100 raised to the 3/2 power, we would say the square root of 100 is 10, and then 10 cubed is 1,000. We might say 125 raised to the 4/3 power. The cubed root of 125 is 5, and 5 to the 4th power is 625. So we'll be doing a lot of this arithmetic in our head, and we will be really needing to rely on this second part of the definition. But here we go. What we're going to do is we're going to practice with some problems. We've got 49 raised to the 1/2 power. Well, that's the same thing as the square root of 49 to the 1st power. The square root of 49 is 7. Now these 1/2 powers, I'd make myself a note, the 1/2 power simply is a square root. So 49, the square root of 49, 7. Easy peasy. Let's try another. Here we have negative 49 raised to the 1/2 power. This negative is not attached to the exponent. So the negative is going to stay, and then we've got 49 to the 1/2 power, which we've already determined is 7, gives us negative 7. Now in this next problem, I'm not sure if we meant to type the parentheses the way we did. I should say or, instead of or, maybe versus. Negative 49 in parentheses raised to the 1/2 power. Well, negative 49 to the 1/2 power, all in parentheses, is the same thing as number 2, the problem we just did. It's still negative 7. However, here we have the square root of a negative. The square root of a negative is not real. So this answer is not real. So these are two different values. One is a value, a numerical value, and one is not real. So it's important for you to pay attention to where those parentheses are. let's try another. 49 to the negative 1/2. Now the exponent is negative. Well, we know when we have those negative exponents, we could just change the position. So this is the same thing as 1 over 49 to the positive 1/2 power. And that would be the same thing as 1 over the square root of 49, which is 1 over 7. Five times a to the 2/3 times 4 times a to the 3/4. 5 times a to the 2/3 times 4 times a to the 3/4. We can multiply in any order, so we can multiply the 5 times 4 first, and then we have the same base, so we'll get to add those exponents. So we'll have 20, retain the base of a, and add the exponents. 2/3 plus 3/4. 2/3 plus 3/4. Well, this first fraction needs a 4, and this second fraction needs a 3. So that gives us a common denominator of 12, and we have 8 plus 9, which is 17. So 20a raised to the 17/12 power. 17 over 12 power. Now, if we're writing this in radical form, this is 20 times the 12th power of a to the 17th. And this can be simplified because a to the 17th, we've got a group of 12 a's in there. So we will have 20 times a times the 12th root of a to the 5th. And if we're rewriting in radical form, that would be the simplified version. 20a times the 12th root of a to the 5th. And that's because when you have 17 a's in there, you've got a group of 12 and 5. So this 12 is going to go, one of them goes to the outside. It's breaking down radicals. You've been doing that since Algebra 1, so hopefully that makes sense to you. Okay, let's see what we've got next. Here we've got a radical. We've got the 5th root of 16a to the 1/3 over a to the 1/4, and we need to simplify this. I think what we'll do here is, since we've got, well, let's do one more radical. We'll do this one more radical, and then we're going to break this into a second video and do the second half. We've got, I think, up to 11 problems, so this is perfect. So we'll do this one right here. This one would be the 5th root of 16, and then we've got a to the 1/3 over a to the 1/4. Now, a to the 1/3 divided by a to the 1/4, we're going to retain that base and subtract the exponents. So 1/3 minus 1/4. And 1/3 minus 1/4 is 4/12 minus 3/12. You will get better at fractions the more you work with them. So this will be the 5th root of 16 a to the 1/12 power. Now this a to the 1/12 power, do we leave it like that? What do we do? So this can be written as the 5th root of 16 times the 5th root of a to the 1/12. I like this answer, but I also like this answer. 16 to the 1/5 power times a to the 1/12 times the 1/5 power. So I'm going to rewrite this fifth root. I can just put in parentheses and then put that 1 on the outside, and that's going to give me a 1/5. So a to the 1/12 times 1/5. And that's going to be a to the 1/60th. So 16 to the 1/5, a to the 1/60th. It would be really nice if these both had the same denominator, and I could do that. I could say, well, this is 12 over 60. 12 over 60 is the same as 1 over 5. And then you can rewrite this much nicer under 1 radical, because you'd have the 60th root, 16 to the 12th power times a. Now, again, this right here kind of complicates things a little bit, in my opinion. There's not a lot you can do when you've got a 60th root here. So I love this answer right here. It all depends on checking your answer with that answer key and seeing which one is going to be the best fit. I like either one of these answers personally, but not all publishers agree with me. So you'll learn the etiquette that the publisher wants by checking your answers with the answer key. Now in the next video, we're just going to practice a little bit more of these rules. We'll take a little bit more of this too. This might have thrown you for a loop right there. Like, how did we go from there to there? Well, in the next video, we're going to do a little bit more of that.